that we are promoting GIST. Okay, what's in it for us? We're just promoting GIST, and we want everyone to say how wonderful it is and to find it valuable. So this helps us in branding and marketing and kind of just to demonstrate our thought leadership. And what are we promising? That, by the way, is this no blatant marketing at the bottom? Is that cut off by a line? Can you read that whole thing?
Yep, we can see the whole slide.
Okay, good, because there's some funny line looking like it might be blocking it out. All right. So we do keep publicly released versions publicly available. We don't require any kind of licensing, no lock-in. It's under continuous development. We have a team of us working on that on a regular basis. And we actually have the it's on Git, and the issues and it's open for anyone to submit issues. Why would you be interested in it? Well, we hope that it would help make your projects go faster, help avoid a variety of rookie mistakes if you're getting into ontology for the first time, learning some of the best practices that we participate in, and also to network with your peers. And we're asking from you that if you do use GIST, you acknowledge it and keep the Semantic Arts namespace. Don't just copy it and change around the namespaces. If you really need to do that, there's a mechanism for doing that. We can talk about that separately if you're interested. And don't create concepts in the GIST namespace. Okay, Melissa, you want to get started?
Yeah.
Let me know when you're ready.
You're good.
It's controlling? Okay, great. All right, so welcome everyone. This is Thursday, August 6th, and today we're talking about dates and times. Okay, so dates. Dates are pretty important. For example, you might know when this tree was planted, or you might know on what date was the fruit ripe to pick. Or you might want to know whose crazy idea and when was it that the idea of a bacon-wrapped date was invented. Or even when was this couple, when did they go on their first date? But it's not just dates we're interested in, we're also interested in time. So, you know, what time can I go have a drink after work today, for example? Okay, Boris. Oh, Boris has just arrived. Okay, overview. So what are we going to talk about in the next hour or so? Well, there's two aspects of managing dates and times. One is an ontology development side. So we're going to look at what support is provided in the language of OWL for dates and times. What isn't there that we'd quite like to have if possible? What are some workarounds? How can we live with the current situation? And some modeling decisions, questions about object properties versus data type properties. And then we'll look at how we do dates and time in GIST. And a second part of this presentation will be relating to triple stores. Once you have your data in a triple store, how can you work with dates? And this may end up being a separate session entirely, depending on how things go. So we'll look at what's in the standard, what works and what doesn't work across what different triple stores, and then what's kind of on the horizon. There are always new versions of Sparkle that people are talking about. Okay, so in the enterprise, dates arise all the time. So here's just a potpourri of them: birth and death rates, when does a blood test take place, what's the date that a price assessment was made. If, let's say, you're pricing Brent crude oil, and people pay for your guesses about what the price of Brent crude oil is going to be when it's delivered to a port in Saudi Arabia, you know, 3 months from now. But when was that assessment actually made? That's important information that's tracked for such companies. Or when was a subpoena postmarked, or when did an employee first start working? So all kinds of dates show up in a typical enterprise application. So quick spoiler alert here. Support for dates and time is definitely not one of the semantic web's grandest achievements. There's a little bit of support, but really not a whole lot. So that's really what the subject of this talk is about. How do we make do? So some of the things to consider about your own needs for representing time and dates. Well, do you care about time zones? Or can you make an assumption for your purposes that everything's happening in one time zone? That's still possible in some cases, but it's getting less and less so, depending on your business. So many companies do business across time zones and whatnot. Do you care about the time? So sometimes you only care about the date, but what if you only, what if you care about the time? Can you handle both of those situations smoothly? do you only care about, calendar dates like January 13th, 2012? Or do you want to say, when was the iPhone released? And all you care about is the month, May 2020, or maybe a decade, the Roaring Twenties, or if you're a geologist, an era which lasts maybe 3 million or 20 million years, the Paleozoic era. So these are all dates, if you like. When do we date this rock, or when do we date this this bone? Oh, that's from the Paleozoic era. So all these things are things that you might conceivably want to do in your enterprise. So what does OWL give you? Well, the good news is OWL did borrow from XML. So there already were data types around for dates and time from XML. So rather than reinvent something new, they just borrowed direct from XML. So that's certainly a good thing. The not so good news is they only, of all the handful of things, they only picked one. What did they pick? They picked XSD date time. So let's have a look at what XSD date time looks like. So what it does is it represents a very specific time down to the second and maybe milliseconds and whatnot on a very specific date. So for example, if we want to say 9:30 a.m. on September 29th, 1977, then we represent it this way: the year, the month, the day. There's a T in there. I guess T stands for time. And then it's 093000. So that's how it's represented. Now, that's no time zone information there. If you want time zone information and you want it to be in universal time, which is Greenwich Mean Time is also referred to as, then you have the exact same thing, but you add a Z at the end. And that just means this is Greenwich Mean Time, or these days it's called UTC. Or you can have a time zone offset. You can have that, but you can say it's 9:30, but this minus 4 hours. So this would be 9:30 a.m. on September 29th, 1977, U.S. Eastern Daylight Time. So that's what it looks like. So what's not to like about this? Well, if you only care about the date and not the time, how do you handle that? That's a question. Trying to get rid of this crap on the side of my screen. Does anyone know how to? Oh, here we go. I'll shrinkify it. Thank you. Okay. What if you only care about the date, not the time? The date time data type in XML requires to have a time sitting there. But what if you don't care about it? It clutters things up. Or what if you want to add a duration to a date and get another date? XML actually has a data type for duration, but there's nothing in it for that in OWL. So now we're going to just look at what to do under these circumstances. So suppose you only want, we'll just take one thing for the moment. Suppose you just want the date, January 13th, 2012, or 9/11, 2001, whatever. Well, there are any number of different things you can do, and I've just picked out 3, and I'd love to have input from the audience, others who have tried other things or who can think of other things that might work. So we're going to look at 3. The first 2 involve staying within OWL DL and using, first one is using a programmatic workaround. Another one is really just to create your own custom date and time constructs, to create your own classes, your own properties, and stay within OWL and kind of proceed that way. Or you can go outside of OWL and just use some of the existing XML data types and then look at what trade-offs there are. So how about OWL with the programmatic workaround? So what this means is, well, let's just stick within OWL. Let's live with whatever inconvenience that puts on us. And we'll use some kind of a convention. We'll just make one up to indicate that you only care about the date. For example, you might just say, if we use all zeros, then let's interpret that to mean it's just the date. We don't care about the time. But what if you really did mean 000000? They really did mean that exact moment when the day just began at the stroke of midnight. Well, maybe if you really want to denote the very first moment of the day, just use 000001 and decide whether you can live without that distinction, whether you really desperately need to have this 000000. Or if you can live without it, then this is a workable approach. However, it is going to require some kind of code because something has to know that if it's 0000000, it needs to be treated differently. So that might mean the output on a field that you might show the data and the time differently depending on what's there. So that's one approach. Has anyone out there actually done this? Because we often, has anyone actually implemented this approach and had it work for them, or tried it or found out it didn't work very well? I'm just interested in people's experience. No. Okay, that's fine. So it is a bit clunky, but it's workable. It's a hack, if you like. It's a workaround. Another approach, which has been taken often enough, is to create your own classes and properties, to provide the support that you need. So Fibo did this in spades. They created this massive, complicated, and it's very quite sophisticated and powerful ontology of time and dates to do all sorts of things. So one of the things that arises in finance and business in general is, what's the next working day? So if it's a Thursday and you want to, for some bank business, what's the next working day? Well, you have to add 3 days and you have to take into account weekends and all this kind of thing. So there is that. And then there's also called an owl time ontology. There's a link there if you want to look at it later on. The W3C. In fact, we can have a quick look right now. Why don't we do that? I'll just show you some of the, is that gonna work? Maybe it's not in slideshow mode. There we go. So there's the time ontology and I'll just show you a couple of pictures here. So here's one. So they have this thing called a temporal entity. And there's an instant, and there's an interval, and then there's a proper interval. I'm not sure what that means. And then there's a date time interval as a kind of proper interval. So I stared at this last night for a while, trying to figure out if it was really obvious what things meant. It takes a little bit of time to get used to it. I haven't studied it very carefully. And then there's something called a temporal position, the general date time description, time position, date time. So there's quite a lot here to get your head around. Again, I'll just put it out to the audience. Has anyone used owl time, and do you have any opinions about it? No. Okay.
Sounds like you're in uncharted territory.
Pardon?
Sounds like you're in uncharted territory. For this
You know
group.
what? My hearing is not so great today.
I'm sorry, I was just saying it sounds like with this group you are in uncharted territory. None of us have tried this.
It's not fully OWL compliant in that it does use XSD date and XSD year and so on that aren't actually allowed by the OWL spec.
I'm sorry, I missed that. Rebecca, can you repeat it?
Well, the time ontology is not fully OWL compliant in that it does use
okay.
some of the XSD data types that aren't allowed in the OWL spec.
Okay, thank you. Did anybody else have a comment? I missed a moment or two. Okay, thank you. Okay, so what do we do in GIST? So in GIST,
I think you want to go back to, Mike, I think you want to go back to full screen mode.
Okay, thank you, Dan. Okay, so what do we do for dates and time in GIST? Well, there's two main classes, time instant, which is a point in time, sort of. We'll get into exactly what that looks like in a moment. And then there's an event, which is when something occurs, which of course occurs over a period of time. So they also has a variety of, excuse me, object properties, things whose values are time instants. So for example, when did something start? And you might have had a planned start time. So suppose you're planning a conference or an event, a wedding or something. You plan for when it's going to happen, and then it has an actual start point. And this is a specific these are both sub properties of start. And similar for end. There's an end time, actual end, and planned end. So these are things that, excuse me, GIST has had for quite a long time. But if you want to represent the date only, then you don't use there's XML data type of date time, you just use a string, and we'll see how that works in a moment. And if you're interested in the time only but not the date, you can also use the string. And you can also represent precision. So, for example, if you're interested in the Paleozoic era or a month or just a year as a date, then you can create a precision. So, what's that look like in GIST? So here's just a screenshot from what GIST looks like with how time instant shows up in Protégé. So there's something called epoch. I think epoch is the standard. There's some arbitrary 0 points. If you want to track that, you can use epoch. Here's how you can specify precision, and this is actually links to just units. A measure of duration is the length of time, like 24 hours, for example. And then you can integrate local date. You can say this is a local date, but because we don't have access to the XML data types, we just get it with workaround, just have it be a string. If you do have an actual date time, if you are interested in a local date time, then you can use date time. And if you're interested in just the local time, then you use a string. And if you're interested in the universal date, just the date only, use a string. And if you want to have the universal date time, then you can use the XML data type. And if you just want the time only, use a string. So this has all been set up to be completely flexible. So whatever you need, you can get it, but it's a little bit clunky perhaps. So what else is going on here? So in practice, we've been using this for quite a long time in our different enterprise model ontologies and loading up triples for our clients. Sometimes you just want a data property for a start time and an end time. You don't want that extra layer. Using time instant as a class whose instances are time instant, they're not data types, right? So what does that force you to do? For example, suppose you have a patient encounter 1, 2, 3, and you want to say it starts. You want to reuse properties whenever possible. No sense in reinventing the wheel. So let's just start because it's already there. But now what do you have to do? You either have to create an actual instance of a time instant, or you can maybe use a blank node. So here's what it would look like as a blank node in turtle notation. So you'd say, what we're going to start, when is this event going to, when did this encounter start? So you went to the doctor to have your ears checked. That's what I'm going to do tomorrow. Anyway, so there's a time instant here. That's an instance of time instant. And then we used universal date time. So that's what one of these options up here that we saw a moment ago, universal date time. And then there's the actual formula, not the formula, but the notation that's used for that. So this is kind of clunky. You can either use blank nodes or maybe create an an instance, but then you have to think of an IRI for it. So this is all a bit clunky. The advantage of doing this is you don't have to create new properties, but the disadvantage is it just adds a lot of gunk that you don't really care about. So what would you want to do instead? Well, how about just create a data property version for these start and end times? So that what would that look like? It's much simpler. So the patient encounter is the patient encounter, and it just adds a start date time. So we're thinking of moving in this direction just to avoid that extra layer. What's not so nice about this is we had, as we saw a moment ago, these set of properties, start, actual start, plan start. So if you want all that, but you don't want the extra layer, then you essentially have to create 6 new properties, and you have to have 2 properties, 1 object property and 1 data type property for each type of a thing that you want for each circumstance. So that's a little bit unsatisfying, but it is what it is. So choose your poison. Another option is to stray from OWL, say, well, let's just use XSD date and see how much trouble that causes. So recall that XSD date is not in the OWL spec. The only thing you get from OWL in terms of dates and times is date time. Now, in my experience, we used to try this, and all DL reasoners years ago used to give syntax errors. So you didn't even have the option to develop your ontology, use XSD date, and get the reasoners to run. That didn't work well. Thanks to Scott, one of our new ontologists, he said, no, yes, it does work, Mike, really, I'll try it. And he's right, it does work. So there is a slight caveat. XSD date is not fully supported by Protege. And RDF and Sparkle don't, well, but here's the caveat. So it's not in there, but the reasoners don't mind. There's a little bit of inconvenience by Protege, but it turns out that's extremely negligible. And RDF and Sparkle don't care about at all. So for me personally, this is just emerging as an attractive option. So you can use XSD, and I did a few experiments. You can use XSD date as a range to a data type property, and you can also use it as a filter and a data property restriction. So honestly, it seems like this is a completely viable solution. So what's not to like? Well, one argument, and it's valid on its face, is it's not in the standard. And there are very good reasons to adhere to standards. But do those reasons apply in this case? So we just had a brief discussion internally this week on this very point, and there are reasons back and forth. So I personally don't see any good reasons for not using XSD date, but I want to open this up to the floor and say, what are people's views, pros and cons? Should we go this way? Or if we did, what are the pros and cons? And maybe different people can do different things, but are there any good reasons not to do this? I'll open this up to the floor.
Michael, can I just back up for a minute? Isn't it possible to use XSD date time with precision 1 day or 24 hours to get a date without a time?
Wait, can you say that again?
Well, I'm not answering your question directly, but I just want to offer another alternative, which I believe to use date time, XSD date time with precision 1 day.
Oh yeah, that's what we did in. That's true. I didn't mention that. We did that with Platts, didn't we? Yeah. So if you want to say so if you want to, thank you, Rebecca, for reminding me of that. If you want to refer to just a day, then you can create an instance of time instant and say it has the precision of 24 hours. That's what you're referring to, right?
Right. Yes.
Yeah. 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 I should have given an actual example, but that's how that would work. Yeah. But that's still a bit clunky because you don't know when the time period started, plus or minus 24 hours. What about a day normally means from midnight to midnight. But if you say precision of 24 hours, it's a bit imprecise, oddly enough.
I guess if you gave the noon as the actual date time.
That's true. That could work. Yep. That's true.
Chances are you don't care to have the precision in the case where you're just trying to nail it down to a day. That's enough precision for what you're doing. Like when the iPhone was released, we don't need to know the time.
Right.
No, I'm not, but that's what precision does for you, is it's saying, I don't really mean it's noon. I mean, you know, it's either 12 hours before or 12 hours after the daytime I'm giving you.
Yeah, it makes sense.
But to answer the question you started with, I'm a bit nitpicky about these things, but I do like to adhere to standards. I believe, especially if you're advertising yourself to clients and you're saying you're using standards-based technologies, then I think it's important to stick to the standards.
Yeah, I generally am in agreement with that, but you have to look past the general purpose and say, why is it important to stick to a standard? So let's say there's 5 reasons why you should stick to standards, 5 benefits that generally are the reason to do that. So let's look at each one of those 5 and say, does that really apply here? Because one of the main reasons is if you don't adhere to a standard, then you can't trust what's going on with tools. But if it turns out all the tools are doing the same thing, then de facto it is a standard. So the benefit of sticking with the standard won't really obtain. And so that's
Well,
really my
I was going
open
to
question.
make a similar argument, basically that it appears to me that the tooling that I know of has also recognized that there's a real semantic difference between midnight and a date, and therefore they have changed this to allow dates to be used. So that de facto standard that Mike was talking about, to my knowledge, has happened. But I would advocate one of the practical reasons for using the XSD date time consistently, and is because when you are in a situation where you are bringing in data from a variety of different data sources, some items will be just a pure date, others will be in a date time, and if you have decided to model in your ontology and your triple store using XSD date time consistently, you can absorb either form of data without disruption, and it also provides an easier template for application development. It just eliminates potential confusion by sticking to one data type. I don't know, and I acknowledge, Scott's very good point that semantically, there is a bit of a difference there, but from a practical standpoint, if within a particular enterprise you say, all zeros represent the date, then you've got an implicit semantic. Yeah, but what if I could the process that kicks off at midnight? It's you run into that problem. The other thing I would say too is that it's very easy to cast a date time to a date. I meant the other way around. Apologies. A date to a date time.
Right. Add zeros. Yeah. If I could piggyback, Dan, on what you just said, I agree with the observation. And I wanted to point out a convention that's very common in relational database systems. And to Dan's point, if you're going to interact with data that comes from those systems, you need to accommodate the convention. The convention is that a date or date time identifies the first instant of some period of time, which is why if that's the way you look at any date time string, whether the time portion is present or absent or is zero or is some time within 24 hours after the date, if you think of it as this string is giving me the first instant to this time period, then if I care how long the time period is, I either know it by convention or by some other information, or I can give it separately in one of two ways, by giving the duration of the time or the another instant, which is the instant just before which the time period ends. Then if you look at all dates and times that way, you can very easily interoperate with systems that use that convention. You know immediately that a date without a time or a date with a time of zero means the first instant of that day. So to use the iPhone was released on such and such a day, your data says it was released at midnight, but what it really means is it was released during the day that began at midnight, and you don't care when. So it works very practically, and it's always disturbed me that just uses precision in effect to mean duration. Precision, semantically means, how sure am I of this instant? Is it plus or minus 12 hours? Is it plus or minus, 12 milliseconds? That's a very different concept than saying, here's an instant in time, some time period began here, and what the time period is given either by convention or by other data elements.
So I'd like to respond to that with 3 different points. The precision is not a duration. It's saying it's almost a certainty measure. It says, I don't know exactly what time, but I know it occurred during this time period, which is not the same as saying this thing had a duration of a day. Second, relying on conventions in general is, to me, not good practice, because not everybody does rely on those conventions, and therefore your data is not necessarily interoperable, nor do people understand the convention who are applying GIST. And finally, you still need precision to distinguish a 00000 date time, which actually means midnight, from one which means that day, if that's your convention. So you still need precision.
Okay, if I could, good objections. I think what's needed here is a clarity, some clarity in what I said. Yes, precision is not duration, but I think if we settle on a convention where we identify the date by noon plus or minus 12 hours, first of all, that's another convention, and secondly, it's a convention that reinterprets precision. So that's what I meant by precision is being used in effect as a duration, because we mean the day regardless of time, but to express that, we're using precision as if it were a duration. And that is a convention. And without that convention, you have a really hard time dealing with dates from different data sources, because one will say noon, one will say midnight, and you don't know if they're talking about instants in time or durations of time. So I think that the precision duration thing is going to, you're going to have a convention, or you're going to have very complex and unreliable logic to say, oh, they both mean the same day, even though one is saying midnight, one is saying noon.
So Ted,
yeah.
Does that mean you recommend, well, so this is all separate from the question of using XSD date or not. You're talking about the viability of workarounds and conventions. Do you have a view on whether using XSD date is a good idea? Would you do it, or why or why not?
I would use XSD date, yes.
Okay.
I would use it, to Rebecca's third point, the convention I'm talking about, which I think is common in most external data systems, is that a date with no time component and a date with a time component of 0 hours, 0 minutes, 0 seconds, and as many fractions as you want are equal. They mean the same thing. And then I think a lot of problems just go away.
So Dan raised the question of doing, having consistency across the board. So Ted, how would you address that? So if you have some people using date, some using date time, how would you address that? Do you think that's just a trade-off you have to live with, and it might be a problem and you'll deal with it, or do you think it won't be a problem?
I'm not sure what you're pointing out. I think what I'm saying is consistent with what Dan was saying.
Ah, is that true, Dan? Do you see it that way also?
Well, I think I thought we were in agreement until Ted said he advocated using XSD date. And then I thought,
yeah, that's how I was seeing a bit of a mismatch too.
Yeah.
Okay, I'm missing the mismatch, so I can't respond.
Well, better XSD date than the horrible kludge.
Yeah. If I may, I would like to slightly shift the conversation to one of the other big elephants in the room here, which is the choice between using the object properties with a range of time instant, just time instant, versus using the data properties. So if we could go back 2 or 3 slides.
I think I might have slides coming forward with that. Oh, no, I don't.
Okay.
No, I don't. Let's see.
Right. So let me keep going back.
I know, it was this kind of discussion, right?
A little more, back a little further.
Do you want the?
Yeah, this one. Or actually, one more back.
Yeah, so you want the This one.
Right, because and back maybe even one more, because initially when I first started working a lot with GIST, I grumbled about the fact that we really didn't have a good data type property where you could put XSD date time in the object of the trail, and because I sort of changed my mind about this because, as you pointed out, Michael, if you want to have some a date time property, then you're going to have to create, if you wanted to duplicate the ones we have here, start, end, actual, start, actual, end, etc., then you've got at least 6 data type properties. Then adding in when around the dates, and you can, if you insist on using just a data type property for these things, then your list of properties is going to keep expanding and expanding for just about every kind of categorize or tag whatever it is you want to say about what happened at that time.
Oh.
And this gives you flexibility in terms of capturing the semantics of your data without necessarily expanding your list of properties in a way that gives you a cognitive load increase.
I love that, and that plays concept of what do you care about enough to give it its own existence that you have to manage versus the ability to detect the semantics of it. I think what you said was just great.
So Dan, this is quite a fact. This is what I wanted, a new idea, an alternative to the 3 that I put out there. So this seems to be exactly that. So in effect, you're creating, not literally, but you're effectively creating subclasses of time instant, but you're just using tagged classes. You're saying this is a date. So
Top of my head.
that's interesting.
Closed, opened or closed date, for like issues.
Oh, I see. Okay, that's okay.
Yeah,
That's a slightly different.
It's on treating that as a kind of range, but that's always seems stupid to me. It's an instant with a granularity of 1 day.
Well, almost regardless of whether you, when you create one of these time instant instances, which is one of those phrases that always makes me go blah blah blah. Time instant of an instance, and then so you'll have your object, like this issue just start this time instant instance, and then that time instance will have a